Bienvenidos, Ushamdi, and welcome CTS231, Section 841 students for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4 or the Connecting Networks V6 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 4.3.2.6, where we're going to be taking our first look at IPv6 access control lists. Now, the IPv6 access control lists are very, very similar to the IPv4 access control lists in terms of how we create them and apply them, but there are some semantics that we need to be aware of. So let's go ahead and dive into the activity. And again, a nice soft landing activity here that's going to actually give us a little bit of an assist in terms of what we're going to be setting up. And then we're going to discuss something as well that Andrew had discovered. He kind of worked ahead and got to this activity before everybody else. And so we'll talk about the placement of the ACL over here on router 3, the block underscore ICMP. All right, but let's first start out here. We're going to configure an ACL that will block HTTP and HTTP access. Now we know that it's going to be over here on router 1. So let's bring router 1 up, and let's also highlight some of the similarities and some of the differences between ACLs for IPv4 and ACLs for IPv6. Now, one of the first things that we want to talk about is ACLs with IPv6. There are no numbered ACLs. Again, let me repeat that. When we're creating access control lists, not the access control entries, but the access control lists with IPv6, we cannot create a numbered ACL. And let's take a look at that. So I just went from user exec to privilege exec with the enable command. Now let's get into configure terminal, into global config. And from here, if I was to say IPv6 and do a question mark, you can see we've got quite a few choices, but we want access list. And now another question mark here is going to give us that context-sensitive help, where we're going to see that the only option available to us is an IPv6 access list with a name. And let's see if this is not a packet tracer quirk, right? Let's come over here to router 1 and we'll go from user exec to privilege exec into global config. And I'm going to say IPv6 access list. And we're going to do a question mark and take a look. There is no option here to do a numbered ACL. Like if I was to say IP access list, excuse me, and do a question mark, if we were to do extended, you can see I have a choice. I can number the ACLs, but with IPv6, it's very, very important to understand there is no such thing as a numbered ACL, right? They will all have names. So definitely keep that in mind when you're working with IPv6 access lists. And so we're actually told that the ACL we're going to create here is going to be block underscore HTTP. And on router 1, I'm just reading through to make sure I'm not missing anything. Okay. All right, so we say IPv6 access list block underscore HTTP. I'm going to do a question mark here. And again, this is similar to the extended. If I had to draw an analogy, I would have to say that the IPv6 ACLs are most similar to the IPv4 extended ACL configuration, in the sense that you can see we kind of get dropped into this sub-configuration mode underneath the config IPv6 ACL global config mode, right? Which is where we're going to be doing our permits, our denies. If we wanted to put some remarks in here, we can do that. And so let's go ahead. They actually give us the first two statements. So we're going to say deny TCP any host 2001 colon DB8 colon 1 colon 30 colon 30. So again, that would be as if we were doing a /128, right? It's sort of a host, I don't want to say a host route, but in essence, that's what we refer to as, say, a host route. But we're going all the way down to the very last bit, specifying this exact host. So we're going to say equal to www, because the task is to block all HTTP and HTTPS access. So I say deny TCP any. So again, from anywhere to host 2001 DB8 13030 equal to www. In other words, port 80. So to block 443, you'll notice we don't have an option here for, HTTPS or wwws. We have to go with the port number. And let's check and see, is that the same over here if I was to say IPv6 access list block underscore HTTP and do a deny, and let's go with deny, and let's see what we're going to do here. So we'll say deny TCP, and let me make sure I match it. Yeah, deny TCP any host 2001, and we'll just say 2001 : 1, and we're going to do equal. Sorry about that. I'm thinking it's going to be a shorter list so we can show you what's in there. So now you can see we've got all these choices here. There is no HTTPS is what I wanted to show you. That doesn't exist on regular iOS either. We've got www. So we're going to have to go with the port number in the activity. And so HTTPS is 443, and they kindly give that to us. Now, another key difference, right? Another key difference at the end of the ACL for IPv6 is there's the similarity, I guess we'll say the similarity first, is that you still have that deny IPv6 any, but there's something that takes place. There's actually two things that take place before that deny any statement at the end of an IPv6 ACL. And this is very, very critical. Is there are two statements that are there. The first, and this is implicit, they're implicitly there. Just like the deny any for IPv6, and you see the same thing with the IPv4 ACLs, right? There's a deny any, but before that deny any with IPv6, there's a permit ICMP any, and it's NDNA, and then permit ICMP any NDNS, right? And those two things stand for neighbor discovery, neighbor advertisement, and neighbor discovery, neighbor solicitation. And this is critical. And so when troubleshooting IPv6 ACLs, if you see these statements, so let me put in here, permit ICMP, any, and what did I say? NDNA, whoops. And let me show the two choices. There's NDNA and NDNS, right? Now, you don't have to type this in. Again, these are implicitly at the end of every ACL, every IPv6 ACL, before the deny any. And the reason that these have to be there is that without neighbor discovery and neighbor advertisement, you're basically disabling IPv6's ability and functionality to discover neighbors at layer 2, right? And the analogy that you'll hear, which is a very good analogy, is that it would be like you're blocking ARP with IPv4. Because if I know an IPv6 address, but I need a MAC address, I send out neighbor discovery messages, ICMP v6 neighbor discovery messages will go out. It'll be a neighbor solicitation saying, hey, I know the IPv6 address that I'm looking for, but I need that layer 2 information. I need that MAC address information. So a neighbor solicitation goes out. If the host on the wire is listening, I get a neighbor advertisement back saying, hey, that's me. I've got that IPv6 address, and since you asked for it, here's my MAC address. So it's the same thing as ARP at IPv4 with IPv4, except we're talking about IPv6. And so to make sure that IPv6 is always functioning properly, these two statements, which again are implicit, they're there auto-magically. So when you are troubleshooting IPv6 ACLs in either, a lab scenario or a testing scenario, be looking for deny statements that deny ICMP any for neighbor discovery, neighbor advertisement, or neighbor discovery, neighbor solicitation. This will break IPv6. All right, so I'm going to pull this back, and let's get the cursor back in here, and let's say no, and then we'll bring up neighbor advertisement, and we'll say no. So we'll pull those two guys out of there. And I'm sorry, the last statement that we wanted to do is, again, we started with two denies. And in fact, how do we see where we're at right now? So do show IPv6 access list. And there we go. So we have these two denies, right? We meet the requirements. Then again, they gave us those commands, but it says allow all other IPv6 traffic to pass. So it's going to be permit, whoops, not permit IPv6, permit, permit IPv6 any, right? And that's the final statement that we're looking for is permit IPv6 any. Now we're going to apply the ACL to the correct interface. So it says apply the ACL on the interface closest to the source of the traffic to be blocked. Now, this is important to point out for our conversation that's going to take place here when we get over to router 3. When we place it as close to the source, right, who is the source? Right? Who's the source? If we read this statement up here, it says logs indicate that a computer on the 2001 DB8 1:11. And so it's this segment right here. Right? So as close to the source. And remember, when we talk about standard ACLs, and that's the other thing, there are no standard IPv6 ACLs. There are no extended IPv6 ACLs. There are ACLs for IPv6. That is it. And they are only named ACLs. So remember that. There's no concept of standard and extended with IPv6 ACLs. So we're simply being asked here to place it as close to the source, and that's what we would typically want to do. That's really the goal with the extended ACL, is to get it as close to the source. Remember, with the standard ACL, we'd want to put it as close to the destination because we're trying to protect right now this server, right? So with IPv4 ACLs, the standard ACL, we would put as close to the source as possible. Right? So either that interface or that interface, because that's where the application of the ACL would be. The question would become, do we want this router to have to take that traffic in? The order of operations is the ACL will be checked before the traffic is sent to the routing engine, right? So we would probably want to catch it there. That way we don't make router 3 deal with the traffic. With an extended ACL, because we can do source and destination addressing, right, we would probably want to apply it here. Even though we could apply it there, we could even apply it here, we could apply it here, right? But the question, it's the same question that would be asked. Do I want to get it as soon as possible, or do I want to let all of this bogus traffic burden this router and then burden this router only to catch it here in an extended ACL scenario? And the answer is no, I want to get it as soon as possible, right? Because I've got these extra things that I can filter on, right? I'm filtering on protocol. So layer 4, I'm filtering on IP, right? I'm filtering on from and to. So I'm filtering on layer 3 and layer 4 information, so I can apply it closer to the source for more granular control as to how that traffic is going to transit the network. And make a decision. Do I want to let router 1 have to deal with all that traffic? Do I want to let router 2, in addition to that, especially over my low speed serial link, do I want that to happen? And the answer is no. So with an extended ACL, right, we typically go as close to the source as possible. And with this IPv6 ACL, we're being asked closest to the source of the traffic to be blocked. So on router 1, it's going to be right here on this interface in the inbound. And again, they give us a nice little assist here in the inbound direction. But these are the things that you need to think about. But also be careful, because we saw the scenario in one of the previous activities where it didn't work out that we would place the extended ACL as close to the source as possible. We wanted to move it a little further away in order to not block other traffic, which is why we'd want to be careful about sticking it here, right? Because we've got other traffic coming through, even though we've narrowed it down to literally PC2, right? You can see this is server 3 is 3030. That was our from. So from any, right? So when we say any, if I put it here, and let me clear this real quick. So when I say any from anybody, if I applied that ACL there in the outbound direction, PC1, all of the legitimate traffic coming from that subnet is now blocked, right? Or I should say this prefix and prefix length, but coming from this network is blocked. And that's not what we're trying to do, right? That's not what we're trying to do. We're trying to grab it from anybody, but on, and it was specific here, the 11.11::0, which is this network here. So we're going to apply that ACL right there. So let's jump in and let's knock that out. And we should see a pretty substantial bump here in the points. So we'll go into interface, and I'm going to assume, let's say, do show IPv6 interface brief. And that's got to be gig 00, or wait, 01, sorry, gig 01. So interface gigabit Ethernet 01. Now, we've talked about a lot of similarities and differences. We've compared and contrasted IPv4 ACLs with IPv6 ACLs. The next point of order is going to be, how do we apply it to the interface? And here's where we, again, diverge just a little bit. So instead of saying IPv6 access list, you can see there's no command for that, right? I got address and authentication. Is that the same, or let's check? Is it a packet tracer quirk? So we come back in here. We go into, global config interface. We want serial in this case, 000:0. If I was to say IPv6 and do a question mark, you can see there is no access list argument here. There's no access group argument here. So we have to go with, and we'll come down to where it's at, traffic filter, right? Access control list for packets, but it's IPv6 traffic filter that we're going to apply. And then we're going to put the name of the ACL, which was block HTTP. Now, we need to determine the direction. Again, it's the same as IPv4 when we're thinking about what direction do we want to make this application. Do we want it in the inbound or the outbound? Remember, it's from the perspective of the router. So is the traffic from the 11::/64 coming in to the gig interface, the gig 01, which is here, or is it going out? What are we trying to do? Right, we're trying to block that traffic inbound because it will be dropped before this router has to make a routing decision. And that is what we want. We're going to get it as close to the source as possible. So that's where we're going to say block HTTP inbound, right? So we make that application and we should see a significant bump. We'll get 10 points. All right, so we've got that in the right spot. So now let's verify what we just did. Let's open PC1's web browser here. And we're going to browse over to either HTTP or HTTPS for the server 3 address, and we'll give the activity here a second. It's kind of hanging up on me. We can see the windows here, but let's bring it to the 4. All right, there we go. So let's go to the desktop, and we'll go to the web browser, and let's see, can we hit http://2001:1:30:30. And this should work, right? And you can see it does. Server 3, packet tracer looks great. All right, hostname unresolved. We got copyrights, image page. All right, so it's still working though, right? You can see that it's working. So now we're going to go over to PC2. Because remember, PC2 is coming from the network that is causing issues here. So we'll pull the web browser up, and this one we'll try HTTP because we know that that works. // and where am I at? 2001:db8:1:30:30. And when I say go, we should see that nothing is happening, right? Nothing is happening here. And that's because the traffic's being blocked. But let's confirm, they ask us to go ahead and run a quick ping. So I'm going to say ping 2001:db8:1:30:30. So do we have reachability with ping? And we do, right? So it shows that we can get through. Now, what it doesn't show is what's another way we could check this. Exactly, we could come back over here to router 1, and I can say do show IPv6 access list. No context sensitive help there. Excuse me. So here is the permit IPv6 any, the 4 matches that we got from the ping. Here is the deny. Take a look at that. And those denies, right, those are coming from PC2 when we're generating that traffic. You see there's nothing here under this next line for the HTTPS. So let's see. Can I generate some traffic via HTTPS that's going to be blocked? So HTTPS, ://2001:db8:1:30:30. We'll hit enter. I'm clicking go. It doesn't show me clicking go, like it'll highlight it, but you don't actually see any action. But I'm clicking it a number of times here, right? Because I want to generate a ton of traffic. You can, well, actually, you see the green lights over here. It looks like they might be responding to that. So I'm clicking a bunch and we'll say, okay, that's great. Come back to router 1 and now we're going to see, we should see something here to the right of the 443 because I've generated, whoa, yeah, I generated quite a bit of traffic there. So 698 matches, right? Kind of simulating the scenario that we've got all this sort of bogus rogue traffic that's flooding over to our HTTP or our web server. And now we're blocking that traffic. Right, so that's an easy way to check to see what's going on. Another way to check to make sure that the ACL is on the interface is to say do show run. And typically what I would say is do show run interface, and let's say gig01. And yeah, I don't think they allow that command in Packet Tracer. So let me just say do show run. And there we go. That's another way to check to see what ACLs are applied to the interfaces. Now, the one that I forget, because I don't use it at all, I usually do this. I'll say do show run and then look at the interface, is the one that I forgot in the IPv4 section, but let's make sure that still works. How about a do show IPv6 interface gig01, not do show run. You'll notice there's no do show run in there. It's do show IPv6 interface. And this is what we're looking for. Inbound access list. So this is another quick way to check to see if you're troubleshooting, hey, do I have something applied to this interface, right? Do I have an ACL applied to this interface? All right, so that is it for that ACL, pretty exhaustive check there. Now we're going to do another one. So create an access list to block ICMP. And again, the logs now indicate that your server, right, server 3, is receiving pings from many different IPv6 addresses in a distributed denial of service, a DDoS attack. You must filter ICMP ping requests to the server. So create an ACL to block ICMP. And we're going to do it on router 3. And so this is where we're going to have a small conversation about the points being awarded here, right? And how they're going to do this application of the points being awarded. All right, so we're going to go from user exec to privilege exec into global config. We're very comfortable now. IPv6 access list. And again, no numbers, only names in the IPv6 ACLs. So here's what we're being asked to do. The name of the ACL, I'm going to make sure I get this right, is block_ICMP, right? So block_ICMP on router 3. Now we're going to block all ICMP traffic from any hosts to any destination. And this should be a pretty easy one, right? So it's going to be deny, and I'll do a question mark here. You can see as ICMP is going to be one of the choices. We could say IPv6, but remember, we don't want to block all IPv6 traffic or TCP or UDP. We want to get ICMP traffic, and we would simply say deny ICMP any. And we could even go down to, do we just want to get the echo replies, the echo requests? And that's, you see where we've got the neighbor discovery, neighbor advertisement, neighbor discovery, neighbor solicitation, the NDNA and NDNS. Remember, those are permitted implicitly. It is implied that those are at the end of every IPv6 ACL before the deny any. Okay, and we're going to allow all other IPv6 traffic to come through. Now remember, since I put this deny on here, this traffic is being allowed on the link, but that is not IPv6, all IPv6 traffic. That's just neighbor discovery, neighbor advertisements, and neighbor solicitations. So we have to say permit IPv6 any, right? And then right after this statement, there would be a permit IPv6 in DNA and a permit IPv6 in DNS, and then there's going to be a deny IPv6 any at the end, right? All right, so that is our ACL, and that is going to be the whole of the ACL. We're going to apply it to the correct interface. So here's where we get into an interesting conversation. So what did we just do with the block HTTP? It told us to apply it as close to the source as possible, which would definitely be, because obviously they walked us through doing it on router 1, so it's going to be one of these three interfaces on router 1. This is the source that we were concerned about. This was the source network causing the issues. That is as close to the source as we can get. And again, typically with extended ACLs for IPv4, right, the same kind of logic applies to the IPv6 ACLs, is we can get it as close to the source, right? That's optimal, putting it as close to the source as possible, because I'm not burdening router 1 with all that traffic. We're not flooding all this traffic to get to here, only to be blocked right there. That's not what we were trying to do with that HTTP. Now the requirement here is to block any or all ICMP traffic from anybody to anybody, right? So from any hosts to any destination, and it's flooding my server here. And so this is a little tricky, because if we're looking at it as I'm trying to protect the server, right, from any to any destination. So to any destination, and this is the key right here, to any destination implies that we want to block the traffic that server 3 could be generating to send somewhere, right? Not just the traffic coming inbound, but block all ICMP traffic from any host to any destination. And so when we look at where we would place it, we created it on router 3, so we've only got two choices here. It's not like we need to determine, well, do I put it here? Do I put it here? Do I put it here? No. We created it here on router 3 is where the ACL lives. So the choice is, do I put it there or do I put it there? And again, with an IPv6 ACL, similar to a IPv4 extended ACL, the question is, as close to the source, right? And if we read this again, the server is receiving pings from many different IPv6 addresses. Well, if that's the case, the only way to get to the server is through this interface, and it would be traffic coming in the inbound direction into this serial interface. When we're reading this up here, right? You must filter ICMP ping requests to your server. So that is the interface where when we read that definition right here, that interface makes sense. So let's see what happens when we put it on that interface. And we'll come down here to router 3. And let's get into, and I'm sure it's probably, what is it? Do show IPv6 interface brief. It's probably 00, oh, well, I thought it would be 000. It is not, it's 001, right? So let's do that. Interface, not gigabit Ethernet, sorry. Serial 001, IPv6. Now, is it access group? Is it access class? No. Remember, it is traffic, and this is one of the tricky things, is that they changed it. It's traffic filter, right? Traffic filter. The name of our traffic filter is block_ICMP, and the direction, right? Is it inbound or is it outbound? And it's kind of confusing because here it says it's receiving pings from many IPv6 addresses. Filter ICMP ping requests to your server. And then down here it says block all ICMP traffic from any host to any hosts to any destination. So let's put it in the inbound direction, because that is what would make sense, right? But when we look in the bottom right-hand corner, you'll notice that we are not being awarded 10 points for this, right? And that's a problem, because I did the application on the correct interface given the trouble scenario outlined here, right? Because again, we come down to that question. If I'm trying to do exactly this, filter ICMP ping requests to my server, do I want to block them here, or do I want to let router 3 process all that traffic and then catch it here? Because if all of those ping requests are a problem, and they obviously are because it's a distributed denial of service attack, if we allow router 3 to process all of that traffic, all of that ICMP traffic that is quote unquote a distributed denial of service attack coming into this router, does that make sense? To let router 3 be forced to deal with all of this illegitimate traffic only to drop it on that outgoing gig 0 interface. Does that make sense to you? And the answer is no, and it doesn't make sense to me. Now, remember, this is kind of tricky. So block all ICMP traffic from any hosts to any destination. So these two statements here, right, are kind of in conflict, right? These are conflicting statements that we're reading. And you'll notice that logically it made sense to put it there. But if I put it here, could we ping router 3? And the answer is no. We would lose the ability to ping router 3. If switch 3 had a management IPv6 address, we would lose the ability to ping switch 3. But again, we're talking about a distributed denial of service attack. So maybe, since we're being asked to filter the requests to the server, maybe the more appropriate ACL is not any. The appropriate ACL, or the more appropriate ACL, would be from anywhere to server 3, right? Similar to what we did here. And that would be just as easy to do, but we've got it. So it's, again, it's kind of tricky here, right? We've got conflicting statements. The ACL is blocking everything. So let's go ahead and apply it to where we're going to actually, be awarded the 10 points. So let me pull it from this interface. We'll say no IPv6 traffic filter block ICMP in. And whoops, we just did that. And now let's go to where we're going to get the points, which is going to be interface gigabit Ethernet 00, IPv6 traffic filter. Remember, it's not access group. It's not access class. It is traffic filter with IPv6 block underscore ICMP. Now, if I'm applying it to that interface right there, this gig 00 interface here, what direction? Is it the inbound that I'm worried about? Or is it the outbound? Because I'm trying to protect the server, right? So again, outbound would be the appropriate application of the ACL. So I would say IPv6 traffic filter block ICMP out. But again, we get the points for it, but is that the best that we can do, right? So if I put it here in the outbound direction, I'm allowing all of that distributed denial of service traffic into router 3, where router 3 is going to be forced to process all of that traffic, only to have it blocked or dropped on this outgoing interface in the outbound direction. So does it do what we expect it to do? It does, right? It blocks all of the traffic outbound, so it's never going to get to server 3. The problem is that we're now forcing router 3 to process that traffic, that it's going to have to route that traffic, attempt to get it out this interface, only to drop it. So when we look at this activity, we have to ask the question, and this was the question that Andrew asked on Tuesday evening, was, is this right? Is that as close to the source, right? If we're following sort of that recommended best practice, that if we can follow it, we do. This is a scenario where, because of now I'll say it like this, a poorly crafted IPv6 ACL statement, an access control entry statement, right, where it's saying block all ICMP traffic from any host to any destination, right? We're kind of coming up with this poorly formed statement here, right, this requirement, where what we should have said would have been deny, what we wanted to say would have been deny ICMP from anybody, but to host, like we did here. I won't write the whole thing out, but you know what I'm saying, 2001, server 3, right? We'll say server 3. That would have been the more appropriate statement instead of this to any destination, because it says any destination, but what is it asking me to do right up here? So again, these statements conflict with each other. Block it to any destination, but then filter ICMP to the server. But that's not what this statement reflects. That statement doesn't reflect blocking it to the server. It reflects blocking it going anywhere. And so then we're kind of forced to back it up a little bit here in the outbound direction. So again, I would say if we're doing this in a vacuum where it's up to us to make the call, that we do that deny statement for just that destination address, because that goes along with that statement right there, that requirements statement that's being put there, and it's on that interface in the inbound direction. Because router 3 doesn't have to deal with it, the switch doesn't have to deal with it, and the server's not going to have to deal with it, right? But we save router 3 from having to deal with that. But we're looking for that 100, right? So, but it's good, right? I mean, this is a great conversation to have right here, because it leads us into the conversation of, are we as close to the source, which would be there, or because of that poorly formed statement that is basically, we're putting the block here in the outbound direction, we end up not as close to the source as possible, right? Or sources in this case. We end up as close to what? Yeah, putting it here, we are as close to the destination as possible. And that's typically not the objective, right? Or not the optimal scenario when we're talking about IPv6 ACLs or extended IPv4 ACLs. We want to get as close to the source as possible, not as close to the destination as possible. Remember, as close to the destination as possible is typically a standard IPv4 ACL. That's the objective there, right? All right, so good conversation, right? Definitely some things to think about, and Cisco is famous for their sometimes more than confusing verbiage on what they want you to do. So definitely something to think about. And that is going to wrap up Packet Tracer Activity 4.3.2.6, where we took a look at IPv6 ACLs. We compared and contrasted a lot, right? Remember, some of the significant differences with IPv6 ACLs is, number one, they're applied with the IPv6 traffic filter argument, not the access filter, or not the access class when we're doing on the interfaces, right? So it's traffic filter. Remember, there are no numbered IPv6 ACLs. Everything is a named IPv6 ACL. There is no wildcard mask. It is prefix and prefix length, or as you saw in this activity, we could do it with the host argument instead of having to do a /128 for a host route. All right, guys, I will see you all on Tuesday evening.